Hello, welcome. We're going to be doing another math homework. We're going to be doing 3.7 piecewise functions. And this is not an easy one. Nope. It's very difficult. So, I hope the examples I have are variety enough to show you what the different kinds are. Here's the thing. When I made the homework, there's two choices of problems in Alex. There's piecewise functions basic and piecewise function advanced. And I'm not going to lie to you, I put 4 of basic and 4 of advanced. Although I'm going to be honest, like the last 4 I felt were easier. Because the way you graph them is a little more straightforward than some of these early ones. It's your opinion. Hopefully by hearing this you'll get the gist of what to do. Please be advised though, while you're doing this, there's various kinds of lines you're going to see. We have complete lines, we have line segments, we have rays, and any of these options are probably going to require some form of closed or open circles to represent some points that are either on or not on part of the line of the function. Alright, also this is going to be heavy on the Desmos here, so I'm going to open Desmos and get this guy ready. And in fact, I think I'm going to split Desmos here, do one of these, there we go. Alright, so it says, suppose this function is defined for all real number as follows. I'm glad I started on this one. This one is actually not possible to do on Desmos. There's not like some kind of not equal sign. I can't do like this or something. No, it doesn't work like that. There's no not equal sign. So technically this is not graphable on Desmos. Sorry. The good news is I mean, you can kind of graph it. Like f of x equals -1, you could literally write y equals -1 and get a picture of what the line should look like. I mean, it's a horizontal line through -1, right? Now, here's the thing that could be tricky, though. You might say, oh, but also 2, right? So is there a line that's also at 2? No. Here's the deal. There's 2 things written here. One is x not equal to 0, and one x equals 0. Now, despite how negative looking not equal to 0 looks like, that's actually better for a function. That means pretty much all the time the function equals -1, with one tiny exception that when you plug in 0, you don't get -1. You instead get the second option, which is 2. So how does that look on a graph? A graph. So first thing you do is you graph -1. So on my Alex over here, I'm going to make an ongoing line through -1. So I click on -1. I mean, I don't even have to click on -1. I click on any 2 points so that it goes through -1. Perfect. You can, as long as you make a horizontal line going through -1, you're doing the top part right. It says everywhere except for when x equals 0. Like, it cannot be true when x equals 0. So what you do is you fill that in with an open dot. So I click on this right at 0. Now notice x equals 0 is right here in the center, but you have to either rise or fall to where the line is and basically put it on the line. So what we have now is we have a line that says -1 all the time, with the one exception that at 0 there is no line. It's just an open space right at 0 and nowhere else. Now the thing says instead of being at -1 at 0, when it equals 0 you actually get out 2. Now you don't get a whole line at 2, you just get one singular point in the whole function at 2. Boop. So think of it this way, it's like they took the line here, put it on the graph, and cut one point out, and instead of it being on the line as it should be, it was risen up to 2. That's what this is all saying. The line is -1 pretty much everywhere except at 0. At 0, when x equals 0, you instead rise the graph to 2. And the way we represent that is by putting a point there. That's literally it. Boop. Alright, good variety here. So on this one, we have 5 different rules. And you're probably like, yikes, that's a lot. Now, here's the deal. You could sit there and graph this all on, Desmos. You could put 2, and then as it was shown in class today, you put -2.5 less than x less than or equal to -1.5, and then you can continue -1. Oh, I won't do too many here. Or will I? I mean, if you do the whole thing, no one's going to get mad. Like, it's your life. It's not going to be wrong if you actually go through and do the whole thing. Should I continue it? You know what? I'll do one more. 0. Negative 0.5 x 0.5. So you'll notice what's happening as I'm graphing this is I'm getting little steps on here, right? We have little steps going up, up, up. And as one step ends, it jumps up to a new step. And as that step ends, it jumps up to a new step. And you can guess the next two are going to happen as well. Now here's the deal. You don't have to use Desmos to graph this to get the gist of like what they're asking you for. If you recognize that a just straight up number represents a horizontal line, you're doing right. Just keep in mind this: if I write 1, Desmos doesn't graph 1 for whatever reason. It will graph y equals 1, and it will graph 1 once you add in the extra rules. I guess I'll add in an extra rule for this one too. There you go. See, once I start adding the rule, it adds the graph. Not 1/5, 1.5. So be careful on that, I guess I want to say. But if you know, like, you don't have to mess with it. Like, here's the deal. I will be making 5 line segments. Now this is a little different from the last problem. The last problem I used a whole complete line. This problem I'm making little segments. Now here's how you can tell the difference. If your problem says x does not equal something, oh, thank you. I got mail. Wait, can you come shut the door? Thank you so much. I got some art. Check this art out. I'm doing math work in here. Bye. Alright, so the last problem had x not equal to, and so when that happens we use a complete full line. There are some other occasions where you might use a complete line, but I think that's probably, at least for this assignment, what you'll be seeing. The other option is line segments. That's what you'll see when you have 2 endpoints like this. Here it has less than and another less than. That's two endpoints being defined, which represents a segment. The third option, which we haven't seen yet, but probably will see, is what do you call this thing? A ray. And the ray has only one endpoint, and the other goes off forever. That's when you have rules that only have x and one inequality symbol. Alright, enough of that describing it. Let's just go for it now. So it's -2, so that means down 2. And that's between -2.5 and -1.5. Basically, that's from my graph. See, -2.5 to -1.5, and it's down 2, and I'm basically just copying it over. But, I mean, if I can read it, I'll understand, like, pretty easily. It's -1, that means down 1, from -1/2 to -1.5 to -1/2. Okay, there was the second one. We have -1/2 to +1/2. We have 1/2 to 1.5. And then we have 1.5 to 2.5. You notice each time I'm choosing the correct type. -2, -1, 0, 1, 2. You'll probably see some steps like this on yours. Now this isn't it. This isn't done at all. You can't just put the segments. You have to actually draw endpoints. We didn't really have endpoints on that last one because it was just like some weird thing where like there was a hole in the graph. These ones we need to apply the endpoints to all these little x's along the way. You have 2 options. Number 1, you should tell from the equation, the less than signs without the equals under it are open. So for this first one, this would be open, and the second symbol would tell us it's closed. Right? You can also use the Desmos graph if you've done Desmos. If you pull it to the edge, like click and drag, see it says undefined, and you'll notice there's a open dot right there at the end, whereas the other end has a filled circle and a number instead of being undefined. Alright, now I gotta go through this for all of them. Now my advice for you to save some time on this is read all the what do you call them, open ones first. So left was open, left and right, right and right. So basically I'm just gonna go through this. Left and right, right, right. And I was choosing those from the symbol. So left, left and right, right and right. That means all these other ones with the equal signs are gonna be the filled ones. So right, right, and then left at the top too. Hooray! Oh, good. Oh, this is good variety, man. I was hoping I was gonna get to see this. I mean, I had some assignment samples today that like were not such a good spread of different types of problems. I feel like by doing these first 3, I've covered everything. Well, I haven't done this one yet, so let's do it. So I'm gonna graph it. So I do 1, x is less than -2. Then I'm gonna do x, -2, x 2. And then we got 1 again, but it says x greater than 2. So what basically I have is this, and if I zoom out you can maybe see it better. We have a horizontal line, a little diagonal here, and then another horizontal line. And if I zoom out, these horizontal lines go on forever. So the way they expect me to graph this is make a forever line going to the left, a forever line going to the right, and then a little diagonal line in the middle. So this is where we're going to get a mix of some stuff we've done. We don't have a going on forever both directions line. We have a segment in the middle, and we have two rays, one ray going left and one ray going right. So I'm going to start with the rays. So the first ray is at 1, going left. Now here's the deal. If you don't know where to write it, use your Desmos graph. This is at -2, and it says comma undefined, but you can tell it's up 1. Like anywhere else on the graph is up 1. So use that to guide you. Use your eyeballs and senses, I guess. So left 2, up 1. And it goes left forever. So anywhere I click that makes the line go left is good. Separately, we have one that starts at +2 and is up 1, and that goes right forever. So we'll graph that. Okay, then in the middle we have something different. We don't have a ray, we have a segment, because the one in the middle has 2 endpoints. So we got one that goes to -2, -2, and +2, +2. Now, depending on the symbols you have, these are just my symbols. Depending on the symbols you have, it might say undefined for part of this. So just keep in mind, if it says undefined, you just really need to use visually. Like I can see it goes left 2 and down 2, right 2 and up 2. And I can't understand why, but for whatever reason, it seemed like the Desmos problem always was these 2s. Whatever, I won't judge. It is what it is. It means everyone gets similar homework at least. Alright, then it says, oh, we graphed it. Perfect. Except for just like the last problem when I made those little steps, I needed endpoints. These little x's at the end need endpoints. Not the x's in the middle of the line, but the ones at the end. So again, use your sense of these things. So if it doesn't have an equal sign, like the first one, it's open. The middle one has 2 equal signs, therefore they're both closed. And then this last one doesn't have an equal sign, so it's open. And then just like I mentioned earlier, you could click and drag on the graphs. Open means it ends with an undefined. Undefined, filled, filled. So there we go. Good. I'm very satisfied by the variety here. Now show me a 4-piece. Okay, I didn't get a 4-piece. Now, what I didn't get, and I'm sad about, is I saw plenty of problems like this with the jump. This is one of those ones with a dot that jumps, right? I did see some people's assignment that looked like this. It had -x/2, and then it had like a jump dot. If you get a diagonal line with one of these little jumping dots here, I mean, that can happen. I just didn't happen to get one, but I'm describing that it is a situation that could happen for you. Did not happen for me. So in my case, I'm going to put y equals 4. Horizontal line going through 4. And this is a forever line. So x does not equal 0 means the line pretty much always is this high, with one exception. X does not equal 0. They don't have to use 0. They could have used 1, 2, 3. If it said x doesn't equal 3, I would have clicked on 3. That just didn't happen to me. So whatever. It is what it is. In my case, though, it's everywhere except for 0. And so what they did was they basically moved that dot somewhere else, and apparently it goes to -3. So there's a nice line with one cutout dot that jumps down to -3. So everywhere you're looking at the function is 4, except for at one moment, instant in time, it jumps to -3. What's my time looking like? 13 minutes. All right. Suppose that this function is defined for all real numbers. Graph the function. Determine whether it's continuous. This has one extra step. We need to determine if it's continuous. That's pretty easy. First, let's graph it. Now, these are perfect examples of what to use on Desmos. Some of those other ones are weird, like the steps. We got the weird jump line, dot line. The one with the 2 rays and the diagonal in the middle. That was pretty normal, I feel like. These ones these are called the advanced problems. They have a little bit more thinking about how you're going to graph it, but I think they make more sense when you're looking at it. So first, let's graph it. Type it in the Desmos, including the rules. X less than or equal to -1. Perfect. And we got -3x plus 1. And we got x is greater than or equal to -1. Oh, my first one wasn't equal to it, just a less than. Whatever. Well, not whatever. It kind of matters. It really does matter. Otherwise, it wouldn't be a function, technically. Alright, so we got 2 chunks of line going on here, right? So what you're going to be tasked with doing is graphing 2 chunks of line. Now these aren't segments, these aren't a single continuous line, these are rays, so I'm going to be using this ray right here. Now you'll notice this has a little pencil icon. what the purpose of this is to help you find points. So when you're plotting, when you make a line on any graph, you need 2 points. Now when it comes to this stuff, you have to have the point where they meet. I cannot feel like you'd possibly ever get this right if you don't include the point where these two things meet. So I would drag and find that negative, well, I mean, you can see it though, left 1 and up 4, negative 1, 4. Now the red function tells me that, but my black line function says negative 1 undefined. But hopefully you can see it's 4 high, so it is what it is, right? Okay, so that means I'm going to put some kind of, here, I can even dot right here, negative 1, 4. I know definitely that's an important place, right? Both my lines are going to come out of that. Now, to graph lines, you need 2 points. So 1 point was negative 1, 4, but then from each of them, you need to find something else. Now, you can use the slope, or as long as you identify something. For example, my black line here is negative 2 and up 5. Now, you notice when I click, it has all these decimals, and it needs to like be precisely aligned. There you go, negative 2, 5. So that's another point, so I could click on that. And then using my ray making tool, I could click on the 2 things, and it makes that part of the line go in that direction. Very nice. Then, for my red line, I could use any other point. The red line goes to the y-intercept, but that's a pretty nice point, 0, 1. So we'll use that, and then I'll connect it. So I'll start with the starting point, connect the second point. There we go. We got 2 bits of a line. Now this is important. Graphing just this is not enough to be right. For whatever reason, Desmos treats it like these X marks are not a point on the graph. They just treat them like it's an empty spot. So you have to say, Desmos, Alex, this is a definite point on the graph. So the way you do that is by using a filled dot to show where the 2 things meet with each other. The reason why you got to show that is because by default, Alex treats everything like it has no equal sign. But one of them has an equal sign. So if one has an equal sign, that overwrites the one that doesn't, and definitely has a dot where they meet. So you have to make sure you include that dot, okay? Alright, that being said, I graphed it. Huzzah. Now there's one other way I could have done this by graphing. See how the slope here is attached with the x? This is negative 1, which means for this one function it was supposed to go down 1 and right 1. But instead I couldn't graph that direction based on the restriction, so I had to go up 1 and left 1. Hence why the line's going this way. Similarly, this other one has a slope of negative 3, which is down 3 and over 1. And that actually did graph, in a way that would make sense to us, because it's kind of weird, though. You don't want to graph backwards if you can help it, so my advice is maybe find extra points or something like that. Do what you can. Okay. So then it says, is this function continuous? The answer here is yes. Here's how you decide if it's continuous. If the lines connect and it form one complete, unbroken piece of math line, then it is continuous. If it jumps, has a gap, etc., not continuous. I'll probably see when that's not continuous somewhere. Alright, I'm going to run through these and do them. So we got 2x minus 1, we got x is less than 1, we got negative x plus 2, we got x greater than or equal to 1. Okay, you can see these are attached, so definitely going to be continuous. Might as well click that right now. Okay, then we have to do the graphing. So you'll notice they meet at 1, 1. And then this green one, the green one on the right over here, is going down 1 and over 1. So I will click where it says, place first point, down 1, over 1. Perfect. That just made the green line. The blue line, on the other hand, is down 2 and left 1. So I'm using the grid to very specifically find points. Down 2... Oh, I gotta click the original. Down 2, left 1. Down 2 and left 1 makes sense, because that one has a slope of 2. And if you go from left to right, it's up 2 and right. Wait, I didn't even... Hey, look, good thing I was saying that. I went down 3 on accident. So from right here, down 2, left 1. Okay, perfect. There. I fixed it. That would have been a mistake. Alright. And then, yes, it was continuous. They all form one giant line. Okay, we're speed running. Try again. Uh-oh. What did I do? Hold on, let me assess my situation. Did I click something like a dummy? Oh, I did the thing. I warned you guys on the last problem, and I didn't do it on this problem. The dot. You have to tell Desmos that these are connected, and this is a filled-in point. Sorry. There you go. Have to put the dot on that. Man, I will feel so bad if somebody misses that on like an assessment. I missed it just now. Alright, I won't miss it on the next two, I promise. Okay, so next two, we got x minus 2. And then x is less than negative 2. Then we got 3x plus 2. And this is x is greater than or equal to negative 2. I'm going to zoom out a little bit so you can see the lines. Fantastic. Okay. I'm going to zoom in so I can see the point. So we meet at negative 2, negative 4. And then this first one appears to go up 3 and right 1. So here's what I'll do. Click the ray, negative 2, negative 4, right up 3, right 1. That covers the green part of my line. For the blue part of my line, it goes down 1 and left 1. So I'll start at the same point. Down 1, left 1. Perfect. Except, I'm not going to forget this dot, confirming that that is indeed a filled-in spot. And this function's continuous too. They connect, they keep forming a line, so continuous it is, I guess. Is it even possible to get one that's not continuous? I have no idea. Will this one be not continuous? It probably will be continuous. I don't know. I can only see so many examples. Here I'm seeing 4. I've seen other examples going on today. They all seem to be continuous. Oh man, sad. It's another continuous one. Well, if you were looking for one that wasn't continuous, if this had been a 5, you'll notice there's a gap right here. That would be not continuous. However, the actual problem does not have that gap, so I guess it's going to be continuous. Alright, so graphing it. They meet over 2 and down 1, and the black line goes up 1 and over 1. So let's see, over 2, down 1, up 1, over 1. There's the black line for my Desmos graph. Then for the purple line, it goes up 2 and left 1 from the meeting point, so we'll do that. Up 2, left 1. Perfect. And that gives it a slope of negative 2 like that. Again, connect the points. Again, they're connected, so it's continuous. Fantastic. Okay, now I have to say this. In the very rare instance that it actually was something like this, you'd have to be very careful. Should I delete this and show you that? Yeah, I should. Let's just pretend for a second this was the graph, and I needed to graph this. I don't know if you'll get this situation. But for the purple line, you'll go at the purple line's place, over 2, down 1, and then go like this. And then for the black line, you will go over 2, down 3. And it goes like that. Now, instead of putting the singular point that connected them on my last problem, you would have to put the correct stuff. So this purple line had an undefined point, and this black line had a filled point, so it could look like this. That's super possible. That is super possible. Apparently that wasn't my graph, though, so back to what it was. Okay, boop, 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 boop. Okay, check. Fantastic. Submit assignment. Cool. Okay, so, I mean, that was a lot. I think the first 4 were just kind of like dumpy problems, but they were very, the assignment question generator, very generous to me. It gave me a lot. It gave me problems with this jump on it, like a solid line with a point that jumps. You'll see that happen when x doesn't equal 0. We had piecewise functions that were in steps, 5 little steps. We had a piecewise function that was a couple of rays and a diagonal line. So we made that. Then I had problem number 4 was more steps. I mean, no, so problem number 4 was more of a line with a jumping point. Then we had some where we had 2 different rules that seemed to connect. They don't have to, but if they do, it's called continuous. All 4 of mine were continuous. So that was nice. And that's pretty much what happened from 5 through 8. Is 5 through 8 the thing you'll see on a test? If you're watching this video and you watched it to this point, you know, good on you. I'll give you some insider information. I think if I were to make a quiz about this, I mean, there probably will be, that I'd be more privy to putting 5 through 8 type of questions on there. Which, as you saw, were very simple. It's simply a matter of, like, finding the point where both things seem to be together, and then just counting off a slope. Like the black line was up 1, over 1. The purple line was up 2 and left 1. And as simple as making a ray in each direction, and then putting a point on it. So I feel like that's the thing I'm more likely to do. Maybe you would see one of these first 4 type of problems here or there. Maybe, I think you'd see less of them, if anything. Hopefully that's good information for you. Alright, that covers it, so I hope that piecewise function assignment goes well. Please feel free to ask me in person and study it, because it's coming on the quiz. Alright, I thank you for watching. I'll see you next time. Goodbye.